Assalamu alaikum. This is the second lecture on software quality assurance. In the first lecture, we talked about software quality assurance. We talked about definitions of software quality. And remember, we looked at software quality from different perspectives. We looked at from the internal software-wise, we looked at from the user's perspective, and we also looked at from different other angles, and we concluded that the quality of software really depends on the perspective of the user, of the stakeholder. But one thing is sure, and that is we would like our software to be free of defects. In the first definition that we talked about, we would want to eliminate all the defects in the software product or services. But we also talked about the fact that in complex, large applications, it's almost impossible to do so. And so we should continue to try different ways and means to get rid of the software defects. And in today's lecture, we will talk about what software defects are. We will see how they negatively impact the services that we offer based on software systems and the products that are based on software applications. Now, one thing is very important, that in the new economy, software systems are playing a very important and major role in the development and advancement of new technologies, new services that are being offered to people all over the world. So now let's look at what software defects are. A software defect is an error. It's a flaw of some kind. It's a mistake, some sort of failure or fault which makes the software unusable, or which makes the software not as wanted by the user of the software. So it prevents the user from using the software for its intended purpose. It may be incorrect, it may produce unexpected results, or it may have some cosmetic things which are not liked by the user of the software. Mostly, industry uses the word software error or software bug for software defects. But software defect is a very good word, and we will try to use this in our discussion throughout the course. However, the word debug or error would mean the same thing. Now, as I said, that software defects range from a very small cosmetic error to a very large and very negatively consequenting to a very negative impact on the applications. The very simple cosmetic type would be that in your software applications you have misspelled words, you have colors which are not liked by the user. These are also considered as defects. But in some cases, you may have defects which will result in the catastrophic human loss or financial loss. Now let's look at some of the examples of these catastrophes, and then you will understand the impact that these very serious software errors can have on the human economies and on human life. और एक और किस्म के सॉफ्टवेयर डिफेक्ट्स होते हैं जिनको हम सिक्योरिटी फ्लॉज कहते हैं. Security is very important for those applications which are running on networks and especially on internet. Increasingly ہمارے applications جو ہیں وہ اب انٹرنیٹ کے اوپر اویلیبل ہیں اور آرگنائزیشنز میں ان کے اپنے نیٹورکس کے اوپر اویلیبل ہیں. تو سیکیورٹی کا بریچ جو ہے وہ ایک بہت بڑا سافٹ ویئر ڈیفیکٹ ہے اور اس کو ایڈریس کرنے کی ضرورت ہے فار آل کمپنیز. یہ ایون فار اے اسمال کمپنی, فار اے لارج کمپنی, فار اے کنٹری, فار اینی باڈی ہو ہیز پٹ دیئر کمپیوٹرز آن اے نیٹورک, they need to worry about securing their computer systems, and security flaws are basically software defects. تو ان چیزوں کو بھی ہم جب ڈسکس کریں گے تو اس کا بھی ذہن میں رکھیں کہ جتنے بھی سیکیورٹی بریچز ہیں وہ بھی سافٹ ویئر ڈیفیکٹس کے کیٹیگری میں آتے ہیں. اب میں آپ کے سامنے چند ایگزامپلز رکھتا ہوں جن سے ہم دیکھیں گے کہ جو امپیکٹ ہے, ڈیوسٹیٹنگ لاس آف لائف اور فائنینشیلس, ول ٹیل یو دی امپورٹنس آف پیئنگ اٹینشن ٹو دا ایریا آف سافٹ ویئر ڈیفیکٹس اینڈ ٹو گیونگ انف ٹائم اینڈ ریسورسز ٹو ایلیمینیٹ سافٹ ویئر ڈیفیکٹس فرام دی پروڈکٹس اینڈ سروسز دیٹ وی آفر بیسڈ آن سافٹ ویئر سسٹمس. اب ایک ایگزامپل آپ کو میں ابھی دیتا ہوں. 1996 میں یورپین اسپیس ایجنسی نے ایک پروٹوٹائپ راکٹ بنایا تھا, اس کا نام تھا ایرین 5. اس راکٹ کے اوپر قریباً $1 بلین خرچ ہوئے تھے. $1 بلین. This is a lot of money, right? اور وہ راکٹ اپنی لانچ کے 1 منٹ کے اندر ڈسٹروائے ہو گیا تھا اور اس ڈسٹرکشن کی وجہ آن بورڈ گائیڈنس کمپیوٹر پروگرام میں فالٹ تھی. تو آپ امیجن کریں کہ جتنی ایفرٹ اس میں لگی اس سسٹم کو بنانے میں, اس راکٹ کو بنانے میں, صرف فائنینشیلز نہیں ہے, there was lot of hard work that is behind this software systems and also hardware. تو میں نے تو صرف فائنینشیل اماؤنٹ آپ کے سامنے رکھی ہے, لیکن جو نیگیٹو افیکٹ ہے ہیومن سائڈ کے اوپر, پروفیشنل سائڈ کے اوپر, وہ اس کے علاوہ ہے. تو امیجن دیٹ $1 بلین لاس because of a software defect. So I wish that had not happened. But this is an example that tells us to spend some time on removing defects from the software products. اسی طرح 1994 میں رائل ایئر فورس نے ایک ہیلی کاپٹر سسٹم بنایا تھا, چینوک. دیٹ آلسو crashed and killed 29 people. And the investigation led to believe us that it was a software defect in the engine's control system. جو انجن کا کنٹرولنگ کمپیوٹر تھا اس کے اندر یہ فالٹ تھی. اس میں نے صرف آپ کو ہیومن لاس بتایا ہے, فائنینشیلس کی بات نہیں کی, کیونکہ آئی ایم جسٹ ٹرائنگ ٹو ہائی لائٹ دی امپیکٹ, دیٹ از نیگیٹو امپیکٹ آف سافٹ ویئر ڈیفیکٹس ود ان دیز ویری لارج اینڈ کمپلیکس سافٹ ویئر سسٹمس. تو اس میں ہیومن لائف ہے, 29 lives lost in 1 minute, and then you have obviously the financial implications of losing very good, otherwise very good helicopter aircraft, and the implications that this loss of life would have on the families and on the society of these 29 people. Imagine that, right? So if software defects are to be blamed for things like that, then obviously we as software professionals have to look at them and take them very seriously. اب ایک اور ویری انٹرسٹنگ اسٹیٹسٹک آپ کے سامنے رکھتا ہوں کہ ان 2002 a study was commissioned by the United States Department of Commerce's National Institute of Standards and Technology. That study concluded that software defects or bugs are so prevalent and detrimental that they cost US economy an estimated $59 billion annually. That is almost a lot of money. I wouldn't even try to compare it with something. But, think about it, $59 billion annually are lost because of software defects, because of software bugs. Obviously, the software has been developed by professionals like me and like you and others. And so it is our responsibility to, again, as I said before, take this quality assurance matter very seriously and try to eliminate defects from our software products. Now, one thing is important, as I said in the first lecture also, that in small applications, in small assignment type applications or even small desktop applications, it is possible to eliminate all if not many defects. تو جو لارج اپلیکیشنز ہیں ان کے لیے ڈیفیکٹ ایلیمینیٹ کرنا آلموسٹ 100% ڈیفیکٹس کو ایلیمینیٹ کر دینا آلموسٹ امپاسبل ہے. اٹس اے ویری ڈانٹنگ ٹاسک. اب کمپیئر کرتے ہیں کہ لیٹس سے کہ آپ کے پاس ایک سی اور C++ کا پروگرام ہے, سم تھنگ لائک دیٹ 125 لائنس. اس کو ہم وی کین ایزیلی سے کہ جی دس از ون فنکشن پوائنٹ. اس کو کمپیئر کریں آپ ایک ایسے پروگرام کے ساتھ, ایسی اپلیکیشن کے ساتھ جس میں 10 فنکشن پوائنٹس ہیں, یا آپ کی جو لائنز آف کوڈ ہیں وہ اباؤٹ 1250 ہیں. اس کو پھر کمپیئر کریں ایک ایسے اپلیکیشن کے ساتھ جس میں 100 فنکشن پوائنٹس ہیں اور اس میں جو لائنز آف کوڈ ہیں وہ 12,500 ہیں, اور پھر اس کو کمپیئر کریں 1000 فنکشن پوائنٹس کے اپلیکیشن کے ساتھ, یا 10,000 یا 100,000 کے ساتھ. تو آبویسلی جو کہ چھوٹے پروگرامز ہیں اس کو آبزرو کرنا, اس کو انسپیکٹ کرنا اور اس میں سے ڈیفیکٹس کو ریموو کرنا ریلیٹیولی بہت آسان کام ہے. میں یہ نہیں کہتا کہ ڈیفیکٹس ریموو کرنا آسان کام ہے, ریلیٹیولی آسان کام ہے جب ہم کمپیئر کرتے ہیں ایک ایسی اپلیکیشن کے ساتھ جو کہ 1000, 10,000 یا 100,000 فنکشن پوائنٹس کے اوپر کنسسٹ کر رہی ہوتی ہے. تو جیسے جیسے سائز اپلیکیشن کا بڑھتا ہے اور کمپلیکسٹی ڈومین کی بڑھتی ہے, ویسے ہی اس میں ڈیفیکٹ ریموول یا ڈیفیکٹ ایلیمینیشن جو ہے وہ مشکل ہو جاتی ہے, اور اس چیز کو آپ کو ذہن میں رکھنا چاہیے. میں ہمیشہ کہتا ہوں کہ سمپل ٹوائے ٹائپ اپلیکیشنس میں ڈیفیکٹس کو ریموو کر لینا بڑی اچھی بات ہے, کرنا چاہیے, لیکن اصل ٹیسٹ ان پروفیشنل اور لارج کمپلیکس اپلیکیشنز میں سے ڈیفیکٹس کو ایلیمینیٹ کرنا ہے جو ان کا سائز بہت بڑا ہوتا ہے. لیکن اس کا یہی طریقہ ہے کہ آپ کی جو چھوٹی اپلیکیشنز ہیں اس میں سے پہلے آپ ڈیفیکٹ نکالیں گے اور آپ کو ڈیفیکٹ ریموول کی ایک عادت پڑے گی, تب آپ بڑی اپلیکیشنز میں سے ڈیفیکٹس نکال سکیں گے. تو اچھی طرح سافٹ ویئر کو ڈیولپ کرنا یہ ایک بہت امپورٹنٹ کام ہے, ایون فار اسمال اپلیکیشنز. آپ چھوٹا کام, چھوٹی اپلیکیشنز اچھی طرح بنائیں گے تبھی اس پریکٹس کو آپ لارج اور کمپلیکس اپلیکیشنس پر اپلائی کر سکتے ہیں. یہ نہیں ہو سکتا کہ آپ چھوٹی اپلیکیشنس تو برے طریقے سے بنائیں, اس کے اندر ڈیفیکٹس بھی ہوں یا آپ کا ڈیولپ کرنے کا پروسیس اچھا نہ ہو, لیکن آپ توقع رکھیں کہ جب آپ بڑی اپلیکیشنز بنائیں گے تو خود بخود وہ اچھے طریقے سے بننی شروع ہو جائیں گی. یہ نہیں ہوتا. پہلے آپ چھوٹی چیز اچھے طریقے پہ بنانا سیکھتے ہیں, پھر اسی کو بڑے سائز پہ یا بڑی اپلیکیشنز کے اوپر لے کے جاتے ہیں. اب ہم دیکھتے ہیں کہ ایررز کی اقسام کیا ہیں. دیر آر ڈفرنٹ کیٹیگریز آف سافٹ ویئر ڈیفیکٹس اینڈ ایز یو کین سی there are number of them: errors of commission, errors of omission, errors of clarity and ambiguity, and errors of speed and clarity. Now let's discuss these different error types or categories of errors. The first is the errors of commission. These are those errors or those defects which mean that something wrong has been done. You have interpreted something incorrectly, and as a result, there is a mismatch from the needs of the customer. اب اس کا مطلب یہ ہے کہ آپ نے ایک فارمولا لیٹ سے کہ میتھمیٹکس کی آپ بات کر رہے ہیں, تو میتھمیٹکس سے انجینئرنگ کی کسی ایپلیکیشن کو آپ نے غلط طور پر سالو کر دیا. دیٹ وڈ بی ایررز آف اور ایرر آف کمیشن. اب اس میں ایک اور چیز انٹرسٹنگ یہ ہے کہ بعض دفعہ آپ کی ریکوائرمنٹس جو ہیں وہ اس طرح ڈاکومنٹ ہوتی ہیں کہ اس کے مطابق آپ نے سلوشن بنایا ہوتا ہے, لیکن وہ ریکوائرمنٹ غلط ہوتی ہے. تو آپ ریکوائرمنٹس کو تو کنفارم کر جاتے ہیں, لیکن پھر بھی آپ کی جو سلوشن ہے وہ غلط ہوتا ہے. اس کی مشہور جو اگزامپل ہے وہ Y2K پرابلم ہے. Y2K آپ سب کو یاد ہے کہ 2 ڈیجٹ ایئر اسٹور ہونا شروع ہوا تھا, اور اس وقت ریکوائرمنٹ بھی یہی تھی کہ 2 ڈیجٹ اسٹور ہو تاکہ اسپیس کو بچایا جائے. ریمبر ان 60s ہارڈ ڈسکس ور ناٹ اویلیبل, اینڈ کمپیوٹر کی جو مین فریم کمپیوٹر کے اوپر جو ڈسک اسپیس تھی وہ لمیٹیڈ ہوتی تھی, اور اٹ واز کنسیڈرڈ اے پریولیج کہ آپ انسٹیڈ آف اسٹورنگ 2 ڈیجٹ ایئر آپ 4 ڈیجٹ میں ایئر کو اسٹور کریں. تو پیپل وڈ اسمارٹلی یوز دیئر ڈسک اسپیس. اب تو ہمارے پاس یہ بہت ایڈوانٹیج ہے کہ ہارڈ ڈسکس آر سو ایزیلی اویلیبل, اینڈ دس ایشو ہیز بین ریزالوڈ. However, that was a problem at that time. And so people definitely in their judgment, best judgment I would say, used 2-digit space for year, for storing the year. But as a result, that became an error for us when the year 2000 came. Because it became 00, and then that would be misinterpreted, that could have been misinterpreted as the year 1900. And so that is an example of error of commission. The next that you just saw was an error of omission. Something has been missed, something has been omitted that should have been there. And typically this happens because of lack of domain knowledge. The requirements engineers or the designers have missed out something which was important, and as a result it would have a dissatisfying impression or feeling on the customer side. And so this is also a very common thing that people, especially on the user community, sometimes forget to tell the obvious things in that application domain. And as a result, the requirements engineers or designers would miss that, and eliminate that from recording in the requirements. And as a result, what happens is that some obvious thing is missed and the customer is very unhappy. And they would say, you should have known this. But requirements engineers have no way of knowing unless they spend some time getting knowledge or reading about the application domain or asking relevant questions. तो अब हम third type of error discuss करते हैं, third categories of errors. These are errors of clarity and ambiguity. ये उस वक़्त होती हैं जब आप एक स्टेटमेंट को मुख्तलिफ तरीक़ पर इंटरप्रेट करें. अब चूँकि रिक्वायरमेंट्स जो हैं ये नेचुरल लैंग्वेजेस में डॉक्यूमेंट होती हैं, मसलन इंग्लिश है, फ्रेंच है, जापानीज़ है, उर्दू है या कोई और लैंग्वेज है, और ये सारी लैंग्वेजेस बाय देयर डिज़ाइन आर एम्बिगुअस. दैट इज़ a word can have different meanings depending on the context of the usage. फिर एक और बात यह है कि अगर आप careful ना हो in using the commas and in using the words and or, then these words can result in multiple interpretations of one sentence. और इसी से आपको पता है कि किसी लैंग्वेज की जो जोक्स हैं वो भी इसी वजह से बनती हैं कि अगर आप एंड और की मुख्तलिफ इंटरप्रिटेशन करें तो यू कैन हैव फनी कोट्स also. So we have to agree that the language results in the errors of clarity and ambiguity. And the fourth type are the errors of speed and capacity. Now, in some cases, you would, as I was just discussing, the errors of capacity have been solved. But in very complex, very processing-oriented applications, speed is still a very important area, a very important dimension for the execution of those applications. मसलन आप इंटरनेट बेस्ड एप्लीकेशंस को ले लें, वहाँ पर अगर नेटवर्क की स्पीड और एप्लीकेशन की स्पीड या कैपेसिटी को आपने इम्पोर्टेंस नहीं दी, so those applications will not become popular. And this is because your server is sitting in one location and lots of people are trying to access that application from different parts of the world. So although for simple desktop type applications the errors of speed and capacity are not an issue anymore, but for network-based application, they still are. And so, they have not gone away. These errors are still there to for us to look and find and remove. And so these are the four categories of software defects, broad categories of software defects that I introduced and discussed in quite a bit of detail. Now, software defects can be found in all sorts of documents. You can find them in requirements documents, you can find them in design documents, you can find them in cost estimates, you can find them in plans, and all of them will have some impact on the end product. But there are 7 major classes of software work products where defects have strong probability of triggering some sort of request for change, some sort of request to जिसको हम bug report कहते हैं ना. So there are 7 work products, 7 areas of documents where you need to pay special attention to, and if you eliminate errors in those 7 origins, I would say, of software defects, then we have a very good chance of developing a software product which can be achieving the ultimate goal of having zero defects in the software product. So let's look at those defect origins. So we have 7 origins of software defects. Number 1 is errors in requirements. Number 2, errors in design. Number 3 is errors in source code. Number 4, errors in user documentation. Number 5, errors due to bad fixes. Number 6, errors in data and tables. And last, errors in test cases. Now look at these origins of software defects. All of them make sense. If we eliminate, make sense in the meaning that if we address errors in each one of these work products or documents, then we can eliminate a vast number of them from our ultimate software product. Let's say, for example, if we eliminate all defects in requirements errors, I'm just for as a hypothesis that let's eliminate all the defects from the requirements. Then as a result, the design will have an input which is defect free. And so we can be confident that if we do the design perfectly and conform to the requirements perfectly, then we can say with some confidence that our product will have almost no defects, because we have not received any defect as a precondition, and we will try to work and develop the design so that as a post condition of leaving the design process, we have no defects in the design. And so is the case with source code. So is the case with fixing, not introducing errors when we are fixing some other errors. And so is the case with other work products. So we have to take each one of them in individual capacity and ensure that these documents, these work products, are defect free. And I'm using the word document as a synonym to the work product because I'm considering source code as a document also. So just to clarify my terminology here. And so if we take good care of these 7 work products or 7 documents individually as well as collectively, then we can be confident that our products are defect free and or at least leading to a defect free executable software product. Now let's look at another thing, that who actually detects the software, who finds the software defects. You can either discover them, or defects can either be discovered by the developers and testers, usually before the application is given to the customer, or we can say that before application is released to the customer. And sometimes defects are discovered by the customers and users of the application after the release. Now, it doesn't take too much technical knowledge. It's a very common sense thing that defects discovered by the customers or by the users are embarrassing for the development team. So as IT professionals, as software engineers, we are better off by discovering the defects ourselves before they have been given to the customer. And that's the ultimate goal of software quality assurance, that not only we eliminate defects, but we also eliminate them before they are given to the customer for use in their professional lives. Now let me just give you two very interesting observations or two interesting rules about defect discovery by the customers. Rule number one says that defect discovery is directly related to the number of users. And it's very intuitive. The more people you have using the software, there's a good chance that they'll find more defects. And this is very intuitive. Rule number two, on the other hand, is not as very intuitive. And that is the defect discovery, that is this process of defect discovery, is inversely related to the number of defects. And that means that if there are many, many defects in the software product, then the process of discovering them, the process of finding them, is inversely related. And that would actually translate to this very simply stated, it would mean that if the product has many defects, then it will become unusable. And once the product becomes unusable, the discovery process is slowed. And if people are not using it, they will not be able to discover defects. And that again leads to the conclusion that we had just made before, and that is that if the defects are discovered by the customer, then it is very embarrassing for the development team. So we do not want our customers to be working on our project as defect discoverers. We want our customers and users to be working on our products as users of the applications, as those who like their applications. So we should concentrate quite a bit on trying to get rid of defects before the release of the software product to the customers. And that is very, very critical. That's the ultimate goal of software quality assurance, that once the customers have their application, they have it in almost defect-free mode. So, all throughout this course, this is our goal, that we will apply different techniques in processes to achieve that goal, to provide the customer with high-quality software. Now let's look at different defect elimination strategies. The first strategy is effective defect prevention. That is to prevent defects from, or prevent bugs or faults or errors to get into the application software in the first place. That is to not have those things, those bad things in our software. And we'll talk about this later. Very interesting, very complex subject. Second is that we need to have high levels of defect removal efficiency. Very simple. We need to have a good response, a good rate on how effective we are in removing software defects before they are given to the customer. And exactly what defect removal efficiency would mean, we will see later in the lecture today. Another way of eliminating defects is to predict defects before the project begins. Again, getting into those very interesting management issues of software quality assurance, that based on our experience, based on the experience of the project, how can we predict that this application will have so many defects, or that, or to guess or to estimate that this project will have certain percentage of defects in the application. The next would be accurately tracking software defects. Where you introduced, remember we talked about the origins of defects. That is where we need tracking now, that this defect originated in any of these 7 work products. When did we discover it, and how quickly we fixed it, and what kind of defect it was. And we'll talk about this later in the course also. We will also want to have useful quality measurements. There are a number of quality measurements, and we'll talk about quality measurements in quite a bit of detail in another lecture. And also, we would want to have high user satisfaction levels, and that would only happen if we have high quality software products and services. So to keep the customer happy, we need to have good quality product. We need to meet real needs of the customers and the users, not that how we understood it, but what actually user really wants. And if sometimes user is confused, to actually educate them and to help them get to find what the real needs of the application is. Broadly speaking, we can say there are 2 strategies for defect elimination. Number 1 is defect prevention and removal, and secondly is removal. Both of these, broadly speaking, defect prevention and defect removal techniques are used by best-in-the-class companies. Best-in-the-class companies are those companies which have achieved good results, and I would say very good results, in defect elimination. Defect prevention is difficult to understand, to study, and to quantify. Because I said that defect prevention is a process in which we would not let the defects come into the product in the first place. And we'll talk about defect prevention in the next lecture. And as far as defect removal is concerned, it primarily consists of 2 main things. It consists of non-test defect removal, and it also consists of testing defect removal techniques. And we'll talk about what these 2 are today. Most of the non-test or non-testing defect removal techniques consist of some sort of reviews or some sort of inspections. These you can say as are direct fault detection and removal. Direct fault detection and removal. While the testing are failure observation and fault removal. So when you perform tests, you see that your software is failing, and then you do something to correct it. While in the inspection or the review process, what you do is you actually look at the work product. That can be design, that can be code, that can be requirements, and try to detect defects and remove them. Now, these are two fundamentally different ways of looking at defect removal or performing defect removal. Most of you at this time would have good knowledge of testing, and some of you may have also some limited knowledge of design reviews or inspections. So we'll talk about them here in some detail, but we'll talk about inspections and reviews in detail later in the course. Now, what inspections are? Inspections are critical examinations of software artifacts by human inspectors, not by code, not by tools, but by human inspectors. For what purpose? For the purpose of discovering and then fixing faults in the software systems. So it is humans who look at different work products. So they are basically inspecting those work products or reviewing those work products. And inspections are critical reading and analysis of software code or other software work products such as design, product specifications, test plans, anything that can be read, anything that can be analyzed, can be put for a review or can be put for an inspection. They are very effective, by the way. Inspections are typically conducted by multiple human inspectors. So you have more than one person. You know, in more formal settings, you would have 4 or 5. In informal settings, 2 people can do the job. And this has to be some coordinated process. It is not ad hoc, it is not random. And you may require multiple inspections phases or multiple inspection sessions to completely inspect a product. And the product has to be not a very large product. You can make them small products out of a large product. And as I said before, that inspections are a way to try to find faults directly by human inspectors. And this process that is trying to find defects directly can be done individually or in group. The inspection sessions are conducted in group, but it is a requirement that the individual inspectors would have inspected the document before coming to the inspection session. So they can find defects before they come to the session, and or they can do it in the session also. And as a result, the identified faults need to be removed as a result of the inspection process, and their removal also needs to be verified that actually those things have been removed from the document. The inspection process varies, but typically includes some planning and follow-up activities in addition to the core inspection activity. As I said, that the planning includes distribution of the document to the human inspectors so that they can have a read-through and they can have an individual inspection of the document. And once the inspection activity is conducted, somebody has to ensure that the faults that have been directly identified by the human inspectors have been removed from those documents. The formality and structure of inspections may vary from very formal to down to very informal walkthroughs, and this depends on the culture of the company, the need of the application, the domain, and so many other things. But one thing is sure, and that is that the process of inspection and the activity of inspection is very effective in finding defects in all sorts of software work products. Now, this was a very brief introduction of what inspections are. Where can we apply? We can apply it to requirements. That is, we can have requirements inspections, we can have design inspections, we can have code inspections, we can have test, plan, reviews and inspections, we can have test case inspections, and also the user documentation, editing, reviews based on those user documents. And so effectively, as I said, that anything that can be documented and analyzed can be put through a review and an inspection process. And increasingly, companies have realized that this is, although it may seem an added work, but results have shown that this is an extremely useful way of detecting defects and then fixing them before the customer uses the product and even before the testing begins. اب ہم کچھ ٹیسٹنگ ٹیکنیکس دیکھتے ہیں ڈیفیکٹ ریموول کے لیے، اور آئی ایکسپیکٹ کہ آل آف یو آر فیملیئر ود دیم. آئی ول بیسکلی ٹاک اباؤٹ دیم اینڈ ول ڈسکس دیم ان ڈیٹیل لیٹر ان دا کورس. جو یونٹ ٹیسٹ ہوتے ہیں وہ بھی اس میں آتے ہیں. نیو فنکشن ٹیسٹنگ ہے، ریگریشن ٹیسٹنگ ویری امپورٹنٹ سو دیٹ وی انشور that we are not introducing defects while fixing other defects. Performance testing ہے، integration testing ہے، system testing ہے. اسی طرح اور بھی اقسام کی جو ٹیسٹنگ ہے وہ ٹیسٹنگ defect removal methods میں انکلوڈ کی جاتی ہے. یہاں پر ایک بات اور ہے کہ جسے کہتے ہیں نا کہ not all defects are equal when it comes to removal. یعنی کہ تمام ڈیفیکٹس ایک آسانی سے ریموو نہیں کیا جا سکتے. ریکوائرمنٹس ایررز جو ہیں یا ریکوائرمنٹس ڈیفیکٹس جو ہیں وہ ڈیزائن پرابلمس اینڈ بیڈ فکسز آر پرٹیکولرلی ڈیفیکلٹ ٹو ایلیمینیٹ. اب آپ سلائڈ پہ دیکھ رہے ہیں کہ سافٹ ویئر ڈیفیکٹ اوریجنس، ڈیفیکٹ ریموول افیکٹونیس کے اوپر ایک چارٹ آپ کے سامنے ہے، اور اس میں ایک طرف ریکوائرمنٹس ڈیفیکٹس، ڈیزائن ڈیفیکٹس، کوڈ ڈیفیکٹس، ڈاکومنٹ ڈیفیکٹس اور پرفارمنس ڈیفیکٹس ہیں، اور آن دا لیفٹ یو کین سی کہ ریویوز انسپیکشنز ہیں، پروٹوٹائپس ہیں، ٹیسٹنگ ان آل فارمس اینڈ کریکٹنیس پروفس ہیں. اس میں جو پوائنٹ ہائی لائٹ کرنے والا ہے وہ یہ دیکھیں کہ جو ریویوز اور انسپیکشنز ہیں دے ہیو دا بیسٹ پرفارمنس فار ریموونگ ڈیزائن ڈیفیکٹس اینڈ کوڈ ڈیفیکٹس، اینڈ ٹیسٹنگ از ویری افیکٹو اینڈ بیسٹ فار پرفارمنس ڈیفیکٹس. باقی یا تو گڈ ہیں یا فیئر ہیں. تو ڈیفیکٹ ریموول جو ہے وہ اٹ سیلف ایک ایسی چیز ہے جس کے اوپر ہمیں کانسنٹریٹ کرنا پڑے گا کہ کن ایریاز میں کن ڈیفیکٹس کے لیے یہ اچھی ہے، اور جن ایریاز میں اس کی پرفارمنس اتنی اچھی نہیں ہے اس کے لیے ہمیں اور ٹیکنیکس یعنی کہ ڈیفیکٹ پریونشن وغیرہ کی طرف کانسنٹریٹ کرنا چاہیے، تاکہ ہم اپنے جو الٹیمیٹ گول ہے وچ از ٹو eliminate defects before the product reaches the hands of the customer اس کو ہم حاصل کر سکیں. اب ایک بات، ایک ٹرمینالوجی ہم نے پہلے اس کا ذکر گزرا تھا، وہ تھی ڈیفیکٹ ریموول ایفیشنسی. وہ کیا ہے؟ ڈیفیکٹ ریموول افیکٹونیس یا ڈیفیکٹ ریموول ایفیشنسی ایک ایسی چیز ہے، اس کو میں ابھی آپ کو بتاتا ہوں، کہ ہم یہ چاہتے ہیں کہ تمام ڈیفیکٹس یا جتنے زیادہ ڈیفیکٹس ہیں وہ کسٹمر کے پاس جانے سے پہلے ہم ان کو ایلیمینیٹ کر دیں. جتنا زیادہ پرسنٹیج وائز ہم ان ڈیفیکٹس کو کسٹمر کو ریلیز کرنے سے پہلے ایلیمینیٹ کر دیں گے، اتنا بہتر ڈیفیکٹ ریموول ایفیشنسی ہوگی. ہم یہ کہتے ہیں کہ مثلا ریلیز، ایک اس کو سمجھانے کا طریقہ یہ ہے کہ سافٹ ویئر کی ریلیز کے 1 سال کے بعد جتنے ڈیفیکٹ ریلیز ہوئے، لیٹس سے کہ 10 ڈیفیکٹس ڈیٹیکٹ ہوئے اس 1 سال کے عرصے میں، اور ریلیز کرنے سے پہلے ہمارے پاس 90 ڈیفیکٹس ڈیٹیکٹ ہوئے، ڈسکور ہوئے، تو ہم ان دونوں کا ٹوٹل لے لیں گے، گویا کہ ہمارے پاس 100 ڈیفیکٹس ہیں، اور 90 ہم نے ریلیز کے سے پہلے ڈیٹیکٹ کر لیے تھے، اور 10 ہم نے ریلیز کے بعد ڈیٹیکٹ کیے تھے. تو اس پروجیکٹ کے لیے یا اس سافٹ ویئر پروڈکٹ کے لیے جو ڈیفیکٹ ریموول ایفیشنسی ہے وہ 90% ہے. دیٹ از وی ہیو بین ایبل ٹو ڈسکور 90% of defects from total defects detected before release as well as 1 year after the release of the software product. تو اس کو اگر میں فارملی آپ کے سامنے رکھوں تو یہ اس طرح بنے گی کہ accumulation of defect statistics for errors found prior to delivery and then for a predetermined period for deployment which is usually 1 year. اس کو ہم کہتے ہیں defect removal efficiency. یہ اسی وقت ہو سکتی ہے کہ اگر ہم ڈیفیکٹ ڈسکوری کا ریکارڈ رکھیں، یا جس کو ہم ڈیفیکٹ ٹریکنگ کہا تھا وہ ہم کریں، تو اس وقت ہمیں پتہ لگ سکتا ہے. اچھی کمپنیز جو ہیں ٹاپ آف دا لائن، they are trying to achieve a defect removal efficiency of 99%. جو ایوریجز ہیں وہ 85 ہیں، 85%, and anything below that, below 80 is considered poor quality software. کہ ان کو اب اس کے اوپر ایفرٹ کی ضرورت ہے کہ they can improve their defect discovery and defect elimination. آج ہم نے مختلف ٹاپکس کے اوپر بات کی ہے. آج ہم نے سافٹ ویئر ڈیفیکٹس کی بات کی ہے، ہم نے ڈیفیکٹ پریونشن کا تھوڑا سا ذکر کیا ہے، اور ڈیفیکٹ ریموول کے اوپر ایک انٹروڈکشن آپ کے سامنے میں نے رکھا ہے، جس میں انسپیکشن اور سافٹ ویئر ٹیسٹنگ دونوں کو کور کیا ہے. ان دونوں ٹاپکس کو ہم بعد میں پھر ڈسکس کریں گے، اور نیکسٹ لیکچر میں ہم کچھ ڈیفیکٹ پریونشن کی بات بھی کریں گے. ٹل دین، اللہ حافظ.